So hi there, cool you Clem. This is a video dedicated to you since I've written you so many messages and I think you're getting like 20% of them. I mean, for superhet I've given you some examples and I would of course like to show you this in practical. But as you know, Murphy's Law, you build a circuit, you build it dozens of times and it always works, and then you build it and it doesn't work. You can't find a mistake, you can't find an error. It just doesn't work. What I wanted to show you was basically a superhet receiver with transistors and some basic components of it. This thing works, it's a mixer oscillator and stuff like that, but it's only very weak. Anyway, I get into some theory about superhet or single conversion receivers. What you need to build is, I don't want to give you a specific schematic, because I can understand that you want to build the stuff by your own, to call it your own project. So here are a few things. First, you will need an input circuit, which is this one, that is like a preselector for your frequency. So you connect this before the first RF amp, and you will pre-tune the radio station to this one. So it's like radio stations on 10 MHz, you tune this one on 10 MHz. Then you have input or intermediate frequency amplifiers. You can either use this circuit, which is a collector circuit. It offers a high input impedance. But I've noticed that this circuit tends to self-oscillate, so you easily get an oscillator if you connect this to there. Also, the decoupling capacitor should be just a few picofarads, because if you make a too small capacitor, it doesn't work, of course. And if you make this one too big, the circuit is pulling out too much current from this here, and this costs you sensitivity and selectivity. So this circuit works well, as does this. So these both can be input or RF amplifiers. Since for RF amplifiers I recommend this one. This is a basic circuit. We are talking about a few picofarads there. Maybe 100 picofarads from the input and 100 picofarads for coupling capacitor. These are just random values you probably want to build your own design. Here is a IF filter. I've seen your video and you say that you want to use a IF can coil from a radio, but I can't get the point. I mean, you take apart a radio to build a radio out of a radio, so that's kind of pointless. I rather recommend you to make an IF filter with a coil and a capacitor, which does work quite well. As coils, you can use these coils. They are looking similar than resistors. Here, for example, is a resistor, and this is one of these coils, which also has a color code on it. And the color code is pretty much like a resistor, and these are measured in microhenries. For example, brown, black, brown would mean 100 microhenries. It also depends on the ring. In this case, it's a golden ring. So if there would be, for example, the same color code, but with a silver ring, it would be nanohenries. But you can use these coils. This is also, if people want to rebuild it, they don't need to get the special IF can that you intend to use. They just can buy these coils from eBay and various stores. So this would be a testing transmitter, two transistor circuit, but that's something else. So on your oscillator, I would suggest you to use a so-called fine-tuned circuit, because if you have this big variable capacitor, you will just jump over a band. For example, there is a station and it's just a few kilohertz narrow banded, and you will just touch it a little bit, it will already jump over the station. So you tune it close to the station and add the circuit here with a varicap, and then you have an additional potentiometer wherewith you can fine-tune your radio station. You can use a red LED because it has some parasitic capacitance, which can be used as varicap. It's important that's a red LED, not a green or a yellow LED. Red works best. Also, you can use a Zener diode there. Of course, the voltage from the Zener diode should be higher than your supply voltage. You need a demodulator, and I recommend this circuit. This is just a random explanation. Here is another random IF amp. This is the same amp as here. And then you can use a 1N4148. You know this typical standard diode there. And this capacitor decouples the RF from the amplifier. And this resistor is like 1 mega ohm, 680 kilo ohms. It makes the diode conductive, so there is less power required to make this diode conductive and the RF being demodulated. Also on the output you will need a capacitor. This can be like 100 nanofarads that shorts out the RF, and you will need this resistor that can be, for example, 10 kilo ohms. Then you get the audio frequency or the speech signal out. And here you have the intermediate frequency in. It's very important to have an HEC circuit, and I'll show you why. So here I have a homemade walkie-talkie, and here I have a CB radio which I'm powering intentionally with 2 less voltage. So I will transmit now without an antenna, which often harms these devices, but I'm using much lower voltage than it's supposed to work with, so it will take it. So I'm talking now, and this walkie-talkie, this homemade walkie-talkie, does not have an HEC circuit. So I'm talking now into this walkie-talkie. Test 1, 2. I think you can hear it a little bit. Okay, you could hear the blowing on the microphone noise. It's a little bit too hard to do, but the gain was right, and you could basically hear what I was talking, if you want to call it like that, into this transceiver. So what I will do now, I'll connect the antenna to this transceiver. Just a second. I have now connected an antenna to this transceiver. That means it makes now a very strong field strength, and this one is not having an HEC, it's running on full sensitivity. Now I'll do it again. As you can hear, it just distorts. So that is what you get. You only get distorted noise if the signal is too strong. So as you could hear, and that was what I wanted to show you with the other circuit as well, if you don't have an HEC circuit and you get in a really strong station, what will happen is that the IF amplifier is going to overload. Wrong button. The IF amplifier here is going to overload, and it will cut off the sine wave. For example, if now in the beginning it was making a good sine wave, and if there was an amplitude modulation, it was having enough space to amplify the amplitude modulation. But now, if the signal is too strong, it's clipping. It's like it's cutting off the upper side and the lower side from the sine wave. It's cutting off these waves, and then, as you could hear, you only get distorted sound. That may happen that you get distorted sound, or even that you may get a signal, but the modulation completely disappears. So here are just some basics about single conversion or superhet receivers. How is an HEC circuit made? Well, you take the RF from the IF stage, then you amplify it again, and convert it to DC pulses, or to DC with a diode and a capacitor, for example. This DC on the output then regulates the input amplifier. That's at least how I solve this problem. So you have, this is just a symbol that you can use a transistor, of course. Here you have the 9 volts and you have a resistor, and here you have the resistor going to your input amplifier. Which one could be this? It could be connected there, or it could be connected there. So what happens is, if there's no signal being received, the HEC circuit isn't doing anything. So it lets conduct this resistor, it lets conduct this resistor, and all the power goes to this input amplifier, which means high sensitivity. Now there is some RF signal present that goes into the HEC. The HEC converts the RF signal into a DC signal, which then takes some power over this line here. So it's not all the power from the 9 volts is flowing to the input amp. Some power is flowing to the HEC circuit, and some lower power is flowing into the input amp, which will cause the input amp to have a lower sensitivity, and that overall will cause the system to work to match the signal to a level which it requires for good demodulation. There's another thing which I would show you if this circuit, which as you said, due to Murphy's law didn't work. It's a so-called mirror signal. For example, you have a 10 megahertz transmitter, and you align your IF amp to you align your local oscillator to 10.5 megahertz. For example, if you're using 500 kilohertz intermediate frequency, then you of course can hear the station. But you will also be able to hear the station if you align your local oscillator on 9.5 megahertz. That's the so-called mirror frequency. And to prevent that, you have this first tuned stage there, and you have the second tuned stage there. So it will at least give you a little bit of separation between these frequencies, but it's not too good at all. The solution for that would be a dual conversion receiver where you have 2 intermediate frequencies. But it's another topic. I even haven't built one of these by my own. But I've built many superhet receivers for shortwave. This one's also a superhet receiver, of course, and I know what I'm doing. So I just wanted to give you these advice, since most of my messages I've typing these 20 minutes, 30 minutes, and then I send them, and they are simply somewhere on the web, but not on your computer as it seems, because you're never replying to my messages except a few ones. And I mean, maybe you don't want to read them, but then you could tell me that you don't want to read them, but I rather guess they are eaten, as I wrote you in another message, they are eaten by this system. So yeah, that's about signal conversion receivers. Of course, it would be neat if you build this one and use a cooled clem-like audio amplifier with 2 transistors like an AB amplifier and not an LM386. That's boring. And oh no, you can do it better. Another thing for construction is general, also on Tesla coils. I can see you building it like, for example, here is the coil and here is the transistor, and you take one wire that goes here from the coil all over the board and on top there to the transistor. Nah, that's not the way you build RF circuits. RF circuits, also on shortwave, are intended to be built shortly. As you can see here on this, of course, due to Murphy's Law not working circuit, I've built everything pretty tiny. This is the way you build RF circuits, and not as I see in your videos, also not for prototyping. 455 kHz is not the supposed frequency. I mean, yeah, radio is using 455 kHz, but feel free to use 1 MHz, feel free to use 200 kHz intermediate frequency. No one forces you to use 455 kHz. It's just a frequency a real radio usually uses. So, about this board that you got from me, or better that you got from Simon, I'll just get to the page and you will see it. Just a second, I haven't prepared it. I should have prepared it better. So, it's about the modulator that we gave to you. So this one, the modulator, Simon has made the PCB which you liked, and Simon also obviously does drive this page and makes the stuff. But the circuit on this board, the electronic, the transistors, the resistors, the design is made by me. I've designed this one. And I can tell you it's a modulator. That means it's a very weak station. You have to directly connect it to your radio. So you have your vintage tube radio, for example. It has a connector for antenna and a connector for earth. And then you can see this black shielded wire here. You connect it directly to your radio. That's why it's so weak. I've also made a RF amplifier for this one, but I was running into FM problems due to Simon's layout. But that's another topic. So it's okay, it should be that weak. It's not a production error, so it's supposed to be that weak. For IF filter, you can also use 2 of these coils and put them close together. And you get something similar like the coil you want to build out. So this coil is like, it's generating a magnetic field around itself, which is picked up by the other coil. It's like the cheap version of a IF transformer that you can align. And how do you get the frequency? For example, you go to Google, and then you type in, hope my battery lasts that long, because I don't know how long the battery from the camera is going to last. You type in LC calculator, LC resonance calculator, for example, and then you can type in various stuff. Here you have the frequency. For example, we have 220,000 nanohenries, which is 220 microhenry, and 470 picofarads. And you can calculate it and see we are nearly getting 455 kilohertz. So you can try around with these values. You can make like 490 picofarads. Okay, let's do 560 picofarads. And there we go, 560 picofarads, which is a normal value that you can buy, and we get into the 455 kHz IF range. So you don't have to buy your special transformer, just use these coils. Another stuff, your DIY FM radio with the tube FM receiver didn't work because exactly what I wrote. There's the coil, and over there is the tube, and especially on FM frequencies, just a wire like this. Just a wire like this length will already like as if it was another additional turn on the coil. So as I could hear from the static, your receiver was basically working. It just was receiving the wrong band. Okay, Clem. So this is a video directly intended for you, as you could see, with this IF stuff and this LC resonance calculator stuff. As I said, you seem not to get my messages, and I also want to say I'm not advertising. I'm usually not advertising, but Clem, if you are interested in RF stuff, check my channel. Take some patience, watch some older videos like 1 year back or so. I've made so many single conversion receivers, so many transmitters, so many basics about RF stuff. You can really learn from that. Okay, Clem. Best regards, Stefan. And as always, your videos are amazing. I like them, I appreciate them. Although I'm not subbed to you, I often check your channel and see your new videos. Okay. Have a nice day.